A jar contains 34 red marbles numbered from 1 to 34 and 48 blue marbles numbered from 1 to 48. A marble is drawn at random from the jar. Find the probability of the given event. Please enter as a reduced fraction. So find the probability the marble is red. Well, there are, they said 34 red marbles and 48 blue marbles. So the probability that it's red is you just add together the total number of marbles in the bin, which is 34 plus 48. And then you put in the numerator the number of ways that you can get a red one, which there's 34 of those red ones. So it's 34 over the total number of marbles in the bin. And let's see, I'll just calculate that quickly and double check our answer. That's 34. Oh wait, that meant this 34 plus 48 is 82. So that's 34 divided by 82. And we get this 41.4146. So let's double check the answer. Well, they're saying 17 over 41. And the reason why is because they're saying they're probably I apologize. It's in reduced, they want it in reduced form, fraction form. So the way you would do that is you would write this 34 over the, what was it, 82? $34 plus 48 was 82. Okay. You write it over the 82. And then you just reduce. So you divide by 2, and then you would get 17 in the numerator, and then divide by 2. And that's 41. That's how they got 41 over 17 over 41. There we go for the first answer. Then they want you to calculate the probability that it's going to be odd. So there are the number of the red marbles. There's 1 through 34. That first one is odd. So it sounds like, and the last one is even. So it looks like that it looks like half of them would be odd. So it would be 17 that are odd from the red ones. And then it looks like probably 24 are going to be odd from the blue ones. So 17 plus 24 all over 34 plus 48 would give us the probability of it being odd. So we'd add that together. 11 and 41, it looks like on the top. That's weird that we had 41 on the top, bottom over there as well. And 8 over 82, which reduces to 1/2, which makes sense because 1/2 of all the numbers are odd, so it makes sense. And we can just double check our answer. Okay, with this next one, it says what is the probability the marble is red or odd numbered? So we write down the equation that we would use whenever we're trying to find the probability of one event or the other event. And that equation looks like this. It looks like the probability of A or B happening is just equal to the probability of A happening plus the probability of B happening minus the probability that A and B happen. Now, this equation is the one used if these two are not mutually exclusive. If they are mutually exclusive, mutually exclusive means the events can happen at the same time. So can we be red and odd at the same time? And the answer to that is yes, you can be red and odd. In fact, the ball with the first red ball here, number 1, that's labeled 1, is red and odd. So we can't just add all the odd numbers and all the red numbers, because we're going to be to find this probability, because we're going to be counting some of those twice. So we would say that these two are not mutually exclusive. So that means we have to use this equation, and particularly this probability of A and B happening, or the red and odd, is going to be something other than 0. So I find the probability of it being red, which was the first probability up here. That was the 17 out of 41. The probability of it being odd is the second probability up there, is 1/2. And the probability that it's both red and odd, what we have to do that is just find out how many are odd within the red marbles, so that's just 17, because half of the 34 are odd. So minus the 17 over the total, which was 82. So that's the calculation that we need to do for part C, because being red and being odd are not mutually exclusive. So we would have to multiply to get the same denominator here. So I would multiply this one by 2, and it would be 34 over 82. So go back to the original fraction. And then I would multiply this one by 41 on both top and bottom. So it would be 41 over 82. So then I would do the 34 plus 41. So it'd be 75 over 82. So I'm adding the numerators there and keeping the denominator the same. That's what happens when we add them. So it'd be 75 minus 17, which is 58 over 82. And then we just divide that by 2 to reduce this number now, to reduce the answer. So that would be 29, I believe, 29 over 41. And I don't think we could reduce that any further. So I believe that would be our answer. Let's double check it. 29 over 41, that's our answer for part C. Okay, then the next one says, the marble is blue or even. The same thing here. These are not mutually exclusive. When things are not mutually exclusive, it just means that they could happen at the same time. You can be blue and even. So we have to use this equation again. I have to use the probability of it being blue plus the probability of it being even plus minus the probability that there's blue and even. So the probability that it's blue is, now that's a little bit different. We have to kind of calculate everything, recalculate them. All right, so the probability of it being blue is, well, it'd be the same fraction we have up here, but instead where we have it being red, but instead of the numerator being 34, the numerator would be 48. So that's going to be 48 out of 82 for the probability of it being blue. And then the probability that it's even is actually the same as the probability of it being odd, is the 1/2. But if we wrote that with a denominator of 82, then we'd have to multiply the top and bottom by 41. So it would be 41 over 82. Now the probability that it's blue and even. So how many are blue and even? Well, that's half of the blue ones are even. So there's 24 out of the total of 82 that are blue and even. So then we would add these numerators together. So 41 plus, that's 89 over 82. Minus 24 over 82. So that gives us 65 over 82. We saw earlier that 82 was 41 times by 2. I don't think anything else divides into 41. It might be 7. When 7, we'll know 7. We would know if 7 went into 40, 42, 40. Should we just check small primes like 2 or 3? But I think 41 is prime, which means we can't factor that any further. So either we just have to check, does 41 or 2 go into 65 to completely reduce this fraction all the way? And 41 does not divide into 65 and 2 doesn't divide into 65. So I think this is completely reduced as is. Let's check our answer. 65 over 82. There we go. All right. I hope you found this helpful and have a good day. Bye.